Hi guys, how are you doing? So today we'll be discussing the problem C in this video for CodeTON round 4. So what does this say? Make it permutation. Okay. So basically this says that there are two kinds of operations which we can do on an array A of length n. That is remove any integer from array A or insert any integer at array A. The cost of those are different. Like the cost for removing is C and the cost for adding is D. Okay, fine. So we'll get on the code later. Let's first discuss how exactly is are we trying to solve. Fine. So basically let's say we have and we have to make this array permutation of any length, of any positive length. We cannot make it a permutation of zero length, but basically, and permutation is basically any sequence of any array which has 1 to n elements. If the array is of n length, all the elements of 1 to n which are distinct, basically all 1 to n elements in an element array basically. So that is what it means. So let's say if it's 1 2 3, obviously it is already an permutation, so the cost is 0. If it is 1 2 3 5 6, then we need to add 4. So adding 4 has a cost of 5. So rather we might do something else in this question. I guess removing 5 and 6 will give us 1 plus 1 equal to 2, because this is C. So 2 is the cost for doing that, right? So basically let's say we have an arbitrary 2587. Okay. So if we want to keep 5 in our answer, it means we'll have to add all the elements from 1 2 3 4 5, right? So how many elements are already present in this? Two elements are already present. If you see this is, if this is I, then I plus 1 elements are already present from 1 to ai, right? Amongst 1 to ai. So how many total number of elements are there? Ai. So ai minus I plus 1 elements are not present yet. Okay, this ai is, I am not saying it is the direct array which we have right now, but I am saying that if this is the array, then for in that case, if the array has only distinct elements in increasing order, then we can say this. Okay, so ai minus I plus 1 into, we have to add these elements, so d will be that. Okay, and we have to, and as we are making permutation of length 5, hence we have to remove all of the values which are behind it. So what is the size of this array? Let's say the size of this array is m. So m minus I minus 1 into C. Okay, this is the answer for this kind of array. Now you will ask, is it always true to keep our answer, to keep the length of our permutation equal to some value in this array? It's actually true for a very edge case. It's not, but I'll just say in general. Let's say you want to make the permutation of, in this you want to make the permutation of size 6. Okay, so for 6, first of all you will have to add this, so it will need a d. Okay, now you have to add all the elements from 1 to 5 again. So add all elements in 1 to 5, add elements which were not in 1 to 5 behind this, right? So basically let's say it is some x, right? And x is basically this, isn't it? And we remove all this, so it is this, let's say y. So if we add 6, our cost is becoming x d plus x plus y. But if we were not adding 6 and keeping it to one of the values in the array, then it would be x plus y. So why, if d is positive, then why should we add any other element, right? Why should we add any other element? Our answer will be, that is the length of the permutation will be one of these array elements, either 2, either 5, either 7, either 8, something like that. You get my point, what I am trying to say? If we add a new element, then we have to take care of that d also. But in a very corner case, you can also see that if we remove all the elements, removing all the elements would require n plus n into C plus d. This value can also be less than our answer. This value we will be minimizing. So basically for all I we will minimize ai minus I minus 1. I have not told you exactly what AI is right now. Like I have told you, it only contains distinct element, right? So AI minus I minus 1 into we are adding these elements, right? So D plus M minus I minus 1 into C plus what exactly will be here. Okay, so this is it for now. Okay, now let's say that this AI contains some duplicate values, let's say 2 2 3 3 4. Okay, so even if you want to make a length of length 3, it's obvious that we will have to remove these duplicate elements. There is no other way we change these duplicate values to certain other value which will give us a lesser cost than just removing them, because we will anyway have to remove them and then we might add something else in their place, but removing them is the constant part which you can see. So basically removing them is necessary. So basically my point is, we'll have to remove all the elements which are extra. Basically we will first count the frequency of all the elements and remove all those elements which have a frequency greater than 1, and basically we'll remove frequency minus 1 elements. We have to keep at least one element of them, right? And then we will add them in this, we will push them in this vector or array, basically A of I, and M is the size of this A. M is equal to A dot size. This is pretty much clear to you, I guess, right? See, and finally we will add this value that is the number of elements we are removing into C. This is the constant which we add, and for all I, we will minimize this expression. Okay, we will minimize this expression, and finally we will take minimum of, let's say if this expression is E, we will take minimum of, our answer will be minimum of E into this, N into C plus D, N into C plus D. This is a corner case which was given in the test case 1 itself, and hence it helped me to get, because it would have been very tough for me to get this edge case if it wasn't given, basically because it contains some proper reading of question, because the question says once ki at any point in the removal of the values, you can make the size of array 0 and then add another elements, but finally your permutation should have a positive length. So basically we are adding this 1, that's why there is no point of making a permutation of 2 if we are removing all the elements, because that will be another D, and I don't see why we should use up another D. Like, that's not logical, obviously, right? So this is for the one which we are adding, and this is for removing all elements, removing all. Okay, I guess you have got the solutions gist. I hope you understood. Now let's get back to the coding part. Okay, so we have taken input, we have stored the frequency. Now we have pushed back. This V is our elements with distinct values, right? And it is sorted. It is sorted finally, although in map it will be already sorted. I don't know why exactly I sorted. And M is the size of this V, and S is I dot second minus 1, that is frequency minus 1 for all the elements. If it has a frequency of 1, then basically we will add 0, or else if it has a frequency of 2, 3, 4, then we will add 2 minus 1, 3 minus 1, 4 minus 1 respectively, right? Then we have to minimize this answer over this expression which I already discussed. S is the value of the number of values which we have to remove anyway, and finally we will have to minimize this over this. So this gives a correct answer, basically accepted, and I hope you understood the solution. If you didn't, please hit in the comment section below. For now it's this only. I guess I'll also upload a solution for D. So till then, bye.